Hello, in this video, I'm going to go over how we can do a one simple t-test in R. More specifically, we will be using t-test t.test function in R's stat package. Okay, so let's get back to our example here. In this example, we are testing a population mean, mu, and in this case, we do have a department store, and the manager determines that a new billing system will be cost effective only if the mean monthly account is more than $170. Again, this is the mean monthly account being equal to or more than $170. A random sample of 400 monthly accounts is drawn and the data are stored in the accounts Excel file. The manager insists that the level of significance alpha should be 0.05. Can we conclude that the new system will be cost effective? Well, I think we put together already the H null and then H1. Let's remember one more time. Remember, we put a status quo always in the null hypothesis, right? Our status quo is the fact that our department manager believes the current status quo is the mean monthly account is less than or equal to $170. In this case, if the status quo is not challenged correctly, we are going to keep the current system. And if actually our data set or the sample of 400 monthly accounts tells us that actually the mean account value is greater than $170, then we are going to keep the new system, right? We are going to install the new system and we're going to give it a green light, all right? So remember one more time, our status quo, whatever is happening right now, is going to be on the null hypothesis H0. And whatever the challenge is going to be always in the alternative hypothesis. The reason is rejecting H null is going to be a strong decision. And if the data set, that the sample size that we have, suggests that we should reject the null hypothesis, in that case, we are going to rule in favor of alternative, the new challenging claim, whatever it is. And therefore, we always put the status quo in the null hypothesis. Okay, so we use greater than sign here. Therefore, this is one-sided greater than hypothesis test. We are going to act accordingly because this is important. Whatever symbol you put in an alternative is going to determine the type of the test that we are going to run. So what do we do now? So remember, number one rule is to check for normality. We are going to go back to the Excel file and then we're going to convert it into R. And we are going to see whether it is this data is normal. And this is our sample, right? This is what it looks like. We already have this Excel file. What I'm going to do, I already posted this R file. I'm going to show you how we can do one sample, one-sided t-test, all right? So you do see my remarks here. Those are comments in green. I already explained what's going on in this code. But the first thing first is to import our data set. So I go to import data set from Excel. I go locate the accounts, Excel file. Here you go. It's here. I open it and I wait for a second. I just double check whether everything is correct. Yes, I do have two columns, one customer, one accounts. Everything looks good here. And I hit import. All right. It is already created as a data frame here, and then you can double check the columns, current columns there. Right, I do have 400 rows. That's good. And I close it. I'm not going to use it anymore. So what happened here is I imported my accounts data set as a data frame, and it created this data frame here in R, right? Alternatively, you could actually import the data frame through a code, read Excel function call, right? And it includes the complete directory into this function, right? So since I already imported it this way, I'm not going to run this. So I will just comment it out. And you will need, if you click on import data set from Excel, if you have not installed read Excel package, it's going to start installing. Actually, it's going to ask you whether you want to install it, and then you will click yes. Actually, you did this in module one. If you already did it, you don't have to do it again. but you want to make sure that you actually call or load read XL data set before you do this operation, because it has to be there. Um, okay. So after I loaded my accounts data set, remember our psych package, right? We use psych package for correlation analysis, and we use it for its simple describe function, right? So let's run these codes, right? As you remember, I put my cursor on line 6, and I'm using a Mac. I hit command and return. It read this psych package, and I'm now running, executing line 7. I hit command and return. It did actually analyze my data and provided the basic descriptive statistics for me for both columns. Well, actually, if you look carefully to customer column, those are just customer IDs. I don't really need their standard deviation, mean, median, whatsoever. Well, if you are running into those kind of troubles, not troubles, but issues, then you could just specifically tell R that you want actually just the accounts column to be worked on. And then if you do it that way, you see it in line 8. And then if you run it, it's only going to give you the statistics of the accounts column. Well, what do we see here? We do see that the mean is $178. Standard deviation is this. Median is 177. Remember our claim. The department store manager agreed that if our hypothesis test resulted in the fact that I do have $170 or more on an average customer account, then I'm going to keep the new system, right? Well, the mean and median tells me that it is higher, but it doesn't have to be that, that way, right? We have to run the statistical test because, some of your customers might have very low averages on their accounts, and some of your customers might have very high averages on their account, and then that's why you might be seeing those mean and median values. So we will still have to run the hypothesis test. But before, we have to ensure that the data is following normal probability distribution. So we can identify normal probability distribution by plotting its QQ plot. And what does it tell us? Well, actually, if each one of these is our data point, accounts value, those are converted into standard normal values, Z values. And if they follow a straight line like this, if they pass this pencil test, imagine that you are having an imaginary pencil and you're locating it on this line, right? If you cover most of your points, then it means that your data is coming from a normal probability distribution. In this case, yes, it is passing the pencil test, right? I can say that my data is following a normal probability distribution. Well, how do we draw this in R? We use QQ norm function. Well, that's simple, right? So all you do is just type QQ norm, open the parentheses, and then call for the accounts column because we are wondering whether our accounts of our customers are following normal probability distribution. And then if you hit control, command, and return, and if you're using a PC, it should be control and enter. It is actually drawing you a nice QQ plot without the line, without the regression line. If you would like to put a regression line on top of it, you will execute this line 12 command. It's going to add a thread line, right, with this color and with this width, okay, on top of whatever you see here. And then let's command and return. You see that it added this blue line, okay? We already made some comments on this line. We know that now it is actually following a normal probability distribution. All right, if we are sure about it, let's go back to our test. So in our test, as I said, it is one-sided because I do see an inequality here, right? It is actually greater than test here, right? I need to do it in R. If you are using R's t.test, you might be using several other things, but the t.test is very reliable, and I've been using it over the past 5-6 years, and it's very easy to use it. What happens here is that I do create an object, one sample t-test. It can be anything. It can be your name. It can be my name, whatever. And then I just create the t-test object and make it or assign it to this variable name that I just created here. The key here is that I would like to keep this in the memory. That's why I do it this way. And t.test is the stats package function. And in the parentheses, the first spot is going to keep your data set, right? So I do call my accounts column in my accounts data set. And I do type the challenging value here, or the constant that I put in my hypothesis test. It is 170. Well, where do I say that this is greater than 170? I'm checking to see the alternative is where you say what kind of symbol you have. This alternative can be greater than, less, or two-dot-sided, okay? Here, it is greater than because my alternative is telling me that this is greater than. And my confidence level, the question is basically telling me to use alpha equals to 0.05. My confidence level is 1 minus alpha, so that should be 0.05. And here I say the paired item here is false. This is basically telling R that this is not a paired data. I already have just one sample. It cannot be really paired. I think the default is false all as well, but I just wanted to use it here so that you could see that you have an option for it. Well, if you forget about all those, what you can do is you can always just say, well, I'm just going to write it on console. Help dot, open the parentheses, t dot test. And let's see what it brings to me. I hit enter. Well, it gets you all you need to know about the t-dot test. Okay. As you can see, let's look at the alternative. Alternative can be greater. Well, if you have greater than sign in the alternative one, you just put greater here. If it is less than sign, then you just put less. And if it is two-sided, you put two-sided. And you can check to see several applications of this package, of this function. Okay, so yeah, alternative can be two-sided, two-dot-sided, less and greater. That's the most important category here because it's going to tell you what kind of test you're going to run. And after you're done, let's run this line 18, and I hit. It created a data frame for me that keeps a bunch of different values, right? It keeps p-value in there, confidence interval, estimate, null value. I would like to visualize them all. And what I do is I call the name here. I execute line 19 now. And it brings me down the summary of these results that it keeps here in the memory. And it tells me that this is one sample t-test. My alternative hypothesis is true, means greater than 170. Let's double check. Yes, I am putting mu greater than 170. That's correct. And it gives me the t-statistics. Well, if I don't know the critical region, t-stats is nothing to me. But this is important. The p-value is 0.009, and which is significantly less than the alpha value, which is 0.05. So my conclusion would be to reject the null hypothesis, right? My null hypothesis is mu, the average customer expenditure is less than or equal to 170. I reject this in favor of the alternative one. Therefore, I should keep the new system. Okay, I should install the new system. It is cost effective. Based on which criteria? My department store manager's criteria, right? Okay, and what else we can do here? As you can see, 95% confidence interval is also given. So it is basically telling us that the lower value is 172.3607, and the upper value is basically infinity, right? And it is also suggesting that the lower limit of this 95% confidence interval is greater than 170. You can also make the same conclusion like we did with the p-value here, that we should reject the null hypothesis and switch to the new system, and it is cost effective. A quick thing to realize here is I keep this t-test in my memory, right? The variable name that I use is one sample t-test, and this is data frame. And you can reach the statistics only. For example, if you don't want to see the whole summary, what you can do here, you can execute this code. You see that It brings out the t-statistics. It can bring out the p-value directly to you, and it can bring out the confidence interval to you directly. Okay, so this R file is already posted. Make sure that you know how to run this R file. First, you need to know how to import the Excel file and then run these t-tests. Well, thank you so much. I will see you in the next video.